I'm Phil. My pronouns are they, them. Thanks. I'm a mom to some plants. I'm non-binary, but I haven't updated my passport gender marker, so I was able to get into this country relatively easily. The border control has fresh fingerprints from me. It's not easy for everybody to get here. I know we also have folks here thanks to external sponsorships like the Umoja Fellowship, and the conference itself has also supported me and supported getting folks here. Building community takes work, and it's intentional effort, and what we build isn't separate from the world around us and the community we work in, even and maybe especially when we're deep in a social networking protocol. Blaine said technology matters, but it doesn't matter more than people, and I don't know, I just really liked that, and I'm not going to be as values forward in this talk as I usually would be, but wanted to just say that. I'm going to talk about atproto at the small scale. I'm going to have a bit of overlap with Devin's talk earlier. I'm going to be a little bit meaner, but I'm going to try and wrap it up and be optimistic, because I'm pretty optimistic. So self-hosting is something that I've spent the most time on so far in atproto. So by that, what I'm going to mean is small versions of services that tap into larger lexicons, third-party lexicons specifically. Just starting my timer so I don't lose track. Okay, and then the other kind is building new apps. So this is like starting from zero, a new app, you want to build it in atproto. And I think these are distinct but related. I've already used the word lexicon here. I think a lot of folks here will know what that means, but I'm going to just generally use it to refer to app-specific data. So atproto is this open protocol that you can build many apps on, and when I say lexicon, I just mean like the Blue Sky lexicon is all the data that Blue Sky uses. And app view is probably a word I'm going to say a bunch. And in this talk, it just means backend. Yeah. So in order to get to the second kind, which we're going to start with, so hosting new apps on atproto, Blaine took us through a great sort of like explanation of what that can look like, what that can be. But I actually want to start with like the choice to use atproto, and especially compared to a more classic app architecture, because I think somebody asked yesterday, like, how can I tell somebody they should use atproto? Like, what is it? And I think it's important to remember like what the alternative is. Like, so you might have a client app, a SQL database, and an API in between. And like, this is a very well-trodden path. You've got choices of frameworks you can use for APIs. You've got choices of platforms and frameworks you can use for the client app. You'll probably use JSON or maybe be fancy and use gRPC or something, but like, it's very well established, and there's not a lot of problems that you're likely to run into that you can't find an answer for pretty quickly. And like, what's the kind of like simple conceptualization of atproto? It's like you take all the data that's inside that backend service and like locked into the platform, and you pull it out, right? We've got personal data servers, PDSs, and we've pulled them outside of the walls of that backend. And if you kind of like squint at it, I'm missing the relay here, but you have a different write path in your app, but otherwise, like, as the saying goes, it's like not that different from writing a regular app. I'm sure all the folks that have like built app views love to hear when people say that it's just like building a regular app, but with a different write path. If you do the classic app architecture and you use something like SQL for data storage, it gives you a lot. And I think it's important to also remember that. So here's a database where we have users, posts, and likes. So users can create posts and like other people's posts. And we have typed data. We have relationships between these different sort of like data types that we can enforce constraints about. We can even do fancy things like having unique composite keys that make sure you can't have duplicate records. And this is very beneficial if you're writing an application, because you know that the data that's inside your app at least conforms to whatever constraints you can put into your schema. On top of that, you get a nice query optimizer for free with like decades of research making it like pretty good at just kind of anything you want to do with it. If you need an index because you've got a slow path, just say, database, please put an index here, and it will do it correctly. And there's tons of tooling for working with this, right? And I think also not to be underestimated is like you have a really clear source of truth for any given data in your system. One thing that kind of came to me as I was thinking about this talk was instead of maybe thinking about what does a system like enable you to build, what does it invite you to build? I don't have a deep philosophy behind this, but I think when designing protocols, like, it's something that I've sort of like felt in atproto at different points of sort of like, oh, it seems like they're really inviting this kind of interaction or like discouraging this. And yeah. Okay, so if you build on a SQL database, you're going to scale up. Hopefully, your app might become successful. And if your app becomes like super, super mega successful, then like at some point you might outgrow your database. This is not going to happen for almost any app that ever gets built. You can go like so far on a SQL database. That's like what I've done for pretty big systems that I've scaled up. But at some point, maybe you hit like Facebook or Twitter scale or something, and you're not going to be able to keep running on a single SQL database. So you might start with read replicas, and at each step here, you lose something. So read replicas, it's like, okay, now you can scale horizontally for all your reads because you have a copy of all your SQL data, but you have this new invariant you have to maintain where if you write some data to your like writer primary store, and then you try to like do a query that reads it, you have to be careful that like you can't read that out of the reader right away because there's a lag between the reader and the writer. And so this is something you like gave up, traded off for higher scalability, and it's something that now all of your developers have to kind of take on themselves to enforce. As we kind of like go down here, that happens more and more. So maybe you like shard your database, you spin out some microservices. Eventually, your like write throughput becomes so extreme and going in so many directions that maybe you put it into a queue that looks a little bit like an event log. You might want to hydrate some responses in advance, so you give up your beautiful SQL fully normalized thing. And at all of these, it's like you denormalize your data. Now you have to do extra work in your development team to make sure you don't write bugs because you have different copies that need to be updated together. I didn't have time to make these diagrams like as kind of closer as I wanted to make it, but I think where I'm going with this, which you probably saw, is like when we say that atproto turns the data service inside out, I think it's important to, or what I would add to that is that it turns like a Facebook or Twitter scale data service inside out. So all these components that you like get at higher scale are kind of like there in atproto, but they're not things that you actually have to deal with for small apps most of the time. Okay, so with this kind of imaginary app that we're making that may or may not hit some scale, I also just wanted to like highlight some assumptions that you have to that are almost axiomatic in terms of like building new apps. So one is that you read more than you write. This is a database called SLED for Rust, an embedded key value store. And if you scroll down to performance, it'll be like a typical kind of performance claim on a database where they'll say like, whatever performance, 1 billion operations and however long with 95% reads and 5% writes. We're going to come back to that because that'll either be true or not true depending on the kind of app you're building in atproto. And durability is, I think, like a really kind of fundamental thing that changes in atproto. So like, you have your classic app backend and somebody makes a new post. And before you say, OK, I got it, you want to write it to the database durably because you don't want to lose people's data. And in a normal app architecture, if you lie and you say like, oh, I got it, and then you lose that data, users will be very unhappy. That's something that like kind of table stakes for any database is this like assumption of like read more than write, and like durability is really paramount. Okay, so let's say we decide to build this app on atproto. Read more than write is probably still going to be true if you're building a new app. So 0 users, new lexicon, you're doing your own thing. You're going to have more reads than write it because it's a normal app. Your data goes into a PDS instead of your own data store with all those constraints. So you're definitely going to want to expect some bad data coming through your lexicon. In a lot of cases, you can just ignore it. But it also means that like if you write a bug into your client app and you start submitting like bad data accidentally, then where before you would be able to reject that bad data with an error in your backend, now all that data is going to go into people's PDSs, maybe, depending on how you set things up, but probably will end up in people's PDSs, and it's kind of like your problem, and you've sort of like lied about, like it actually is durable, but you're rejecting it in your app view because it's invalid. And the last one is, I think like an important loss from atproto is that because everything's coming through this event log from different people's PDSs, the sequencing of events, like there is no global universal clock. So if somebody writes a post and somebody likes that post, which happened first? In our SQL database, we said like a like has to refer to a post that exists, and that's a nice constraint to be able to have. But if somebody makes a like, you can't assume that just because you haven't seen the post yet means it doesn't exist. So that's extra complexity you have to take on. There's some cool things, like that durability requirement that most databases take as table stakes is kind of, like at least from your app view, the database that you're putting in there, you don't really need it. As long as you don't corrupt your database, and as long as you're committing like with some frequency, like literally 72 hours if you want the most extreme version, but like the event log through the relay gives you replay. So as long as you're committing like consistent kind of markers, you can just rewind and get people's data. As long as it landed in their PDS, you'll be able to get it back. There's a limit to the replay. If you're on Jetstream, it's 36 hours. If you're on the relays, I think as deployed, they're 72 hours. So you better fix your app in that time, or you're going to have a bad time. And you don't get to do back pressure against PDSs. So if your app goes viral, if you have networking issues, if anything else kind of like starts happening like that, that would disrupt your ability to process events as they're coming in, then you might have a bad time. Again, this is like mostly a future issue for bigger apps, but like looking again at the classic app architecture, if you go viral and you can't handle the load, you start rejecting events and people are unhappy because they can't post, but the app is telling them they can't post. It's not telling them, oh, your post was submitted, but now you can't see it. And you might need more write performance overhead than you think, because if you are down and you need to replay, then it's like a kind of different incident mode where with the classic app architecture, you're back online and it's like, okay, we're back, everything's good. With atproto, it's like you're back online and now you have this backlog that you have to churn through before you're good. And if your sort of like write performance overhead is only 2x, then you're down for 1 hour. It's going to take like 30 minutes just to reach where you are, and now you're 30 minutes later. Like, you have to be able to process a lot of write. Okay, so I'm still excited about atproto, despite all that. And I'm going to switch gears over to self-hosting, which is what I've spent a bit more time on. And I'm going to try and tie it back together. Okay, so I wanted to show likes on posts that I was receiving through the Firehose, and that was difficult without, like, I think there's a Blue Sky XRPC endpoint to do it, but I didn't want to use Blue Sky's infrastructure. I wanted to self-host, and so I decided to build a backlink aggregator, and I decided to start with likes. So to get into what that all meant, I'm going to kind of like, so we have these different PDSs in atproto where like everybody has all their own data. That also includes links. So for example, this is a like that I made yesterday from the Blue Sky app. This is atproto browser, a really awesome tool to be able to inspect atproto detail from people's PDSs. And so this is the like I made. It's got the type there, Blue Sky like, and the subject is this thing that is called a strong ref, and it's got this link-looking thing. Oops. This link-looking thing and a CID. We're going to ignore the CID for now and just say that like this link is what makes a like in Blue Sky. So I own the like. The post I liked doesn't own the like. It's mine, and I like a post by creating a link to that post. So if you want to know about everybody who liked a post, you have to be listening to all the likes that are happening and aggregating them somehow, because otherwise, like, am I going to crawl the whole network and see everybody's likes to see which one point to this post? So we've had a few kind of like talks about the PDS, so I'm going to kind of go a little quickly here, but actually just want to shout out atp.tools, which is another PDS browser. So I showed you my side of that interaction, which was creating the record. And then this is another PDS browser where I can follow that link through and see what the post was. And so this was the post. And so yeah, we have these like two different records, and they link in one direction. Every social interaction in atproto fundamentally is a link. You're interacting by creating some content in your PDS, and the interaction happens because you created a link to a record in somebody else's PDS. Okay, so what database are we going to put this huge aggregator in? I kind of have a wrong answers only approach whenever I see a new interesting problem. So I was like, I don't know, how far will SQLite go? Far enough. You can aggregate all likes in the Firehose with SQLite. I made a little demo with the ATproto browser, Tom Sherman's tool, and it showed all the likes on records, and that was kind of cool. So I was pretty optimistic. I thought I would hit a performance cliff once I hit like overflowed the write-ahead log or something, but it actually just like kept working. But it was actually like very close to the ceiling of write performance. And when I started looking at all the like events happening in the Firehose, it was like, okay, no, SQLite, I'm not good enough at SQLite to make it happen. I want to see somebody make it happen in SQLite, but it's not me. Yeah. Yes, synchronous off. There's a lot of knobs to tweak in SQLite to make it run well and fast. the durability one is kind of like part of why I said durability there is because there's durability settings you can set in SQLite, and I think those would have helped gain a lot, but I actually couldn't put it below normal because they don't guarantee corruption and safety on crash. So it's not just that you're giving up durability, you're also giving up corruption. Okay, it doesn't really matter how I built this, but I kind of treated SQLite like a key value store. It was really bad. Strings just joined with a little upsert thing. And then I did this, which is really bad. Wrong answers only, again. And if you've built something on atproto before and tried to support deletes, then you might see what's happening here. That like that I created has a link to the post I liked. And in my database, I'm storing the link target, like it's all indexed by the link target with a like kind of blob of likers. Again, this is probably not how you should do it in SQLite, but what that means is that the only way I can look up that post is by the target that it was linking to. And unfortunately, when you get a delete event in the current Firehose, all you get is the information about your own repo. So here's yet another PDS browser, PDSLS, and we've got, oh, this is wireless, cool. Okay, so we got like, the post I made has this R key, the 3LK thing. It's in my likes collection, and that's my identity there, did PLC. So all of this is the content, but that's sort of like the address. So when I delete this record, all you get is the address, none of this content. So in my schema, I can't go back to find the right target to look up and remove myself from there. So I did the worst thing possible, which is just create a big table of deleted likes, and then whenever you ask for a like, it just says for each one, has it been deleted? It did work. I'm gonna do like a super quick tangent on the delete events and what's invited to kind of bring it back to that question. So this was one of the first things I made on atproto. It's a live feed of all deleting posts from Blue Sky. I'm gonna close that because there's no official policy that I agreed to not to put live Firehose content on the screen. But also, anyway, I think that app wasn't invited by the protocol, and in fact, it was kind of hard because you don't get the content when you get deletes. It has to actually keep a cache of all post records so that when a delete comes in, it can look up what was just deleted and expose it. But there's a change to the protocol right now with sync 1.1 where the deleted content will be included in the Firehose, right? It's not just the hash, it's the content of it? It's just the hash. Oh, okay. Okay, I've gone back and forth about how I feel about it because I thought it was exposing the content, which would have invited more things like that, which I think is like not good. But it would also make like supporting deletes for any third-party app, if it was there, it would make it so much easier because everybody has to maintain these like forward records right now in order to support deletes. So I guess we have to keep doing that. Okay, so my little app view is on the Blue Sky lexicon, which is huge. I'm starting with 0 users that care about my little likes indexer. So I think Jazz told me the other day that Blue Sky's infrac is about a 50-to-1 read to write. Don't tell me things if you don't want them on slides. We'll put them on slides. Yeah. Okay, cool. And so I've made this indexer thing. wanted to pull up the dashboard because I think it's kind of funny. Like, this is a 24-hour view in Grafana, asking it to give me a bar chart. These bars don't seem like they're scaled correctly. So if we set the maximum manually, we see that 164,000 reads in 24 hours. I'm not getting zero traffic, but I'll just keep adding zeros. Is that? Yeah, that's it. Yeah, that one. Anyway, my reads to write are 340 in the other direction. Whoops. Yeah, 340 in the other direction. So a really extreme opposite of a kind of axiomatic truth about building new apps, right? You read way more than you write, and it's like, no. If you're building something on an existing lexicon, you're writing way more than you read. Okay, I already mentioned that. So yeah, I think that a lot of these assumptions make something like choosing a database kind of a weird challenge, because all the traditional advice that you'll find on the internet about how do you pick a database, or someone like me who's I've scaled SQLite to millions of users but never needed to go beyond that, and it's okay, now we got to go beyond that. So I spent a long time testing out different key value stores. These were some of my performance tests, spent a lot of time making nice graphs. If anybody has questions about specific data stores, I would be super happy to talk more, but I'm going to keep running. I'm going to pause on this one because this light blue line, this is how many events per second it's processing from an empty database. So as time goes on, they all kind of fill up and get worse. But the light blue one here, that is somehow that's SQLite. Up until about 5 million writes, if you crank up the write-ahead log settings in SQLite, you can get ridiculous write performance. They've really made their write-ahead log efficient. Okay, skipping ahead, something funny happens with databases here. And we also get some really funny disk space usage charts. And I'm gonna, no, there's one more later. Here's my read performance charts. This one is a total lie, but it's one of the favorite charts I've ever made, which I can explain to anybody who's interested. But yeah, I've used Redis a bunch. I thought that's what key value stores were. Turns out, if you really get into key value stores, then mostly what you're talking about is byte keys and byte values, and storing them either in a B tree or some variation, or a log structured merge tree. And there's two kinds of performance characteristics here. There's one that's bad, and there's one that's kind of incredibly good. The B trees are all at the bottom there, and the LSM trees are at the top. So it took me quite a long time to learn that LSM tree, you hear they're better at writes or whatever, but they're kind of fundamentally better at writes. And I'm not going to talk more about those, but I thought I was going to talk more specifically about data modeling, and would also love to chat more with folks, but I couldn't quite pull it together to fit it in this talk. Okay, so the thing that is the backlink index that I built, which is now not just likes, but it's all interactions in atproto across all lexicons. The way it does that is this. I was trying to just get this thing working so that I could finish a blog post that I wanted to quote it for. So I'm not showing this to show good code, and you can find at least 2 problems that you could probably go and mess with things right now if you really wanted to. But just to say that it's pretty simple. It's walking the JSON of every record that comes through the fire hose, and then that bottom thing there is whenever it sees a string, so it'll recurse into any object or array it finds, and whenever it finds a string, it makes an attempt to parse the whole string as a link, a DID, a URL, or a @URI, and if it finds it, then it indexes it. Okay, gonna run ahead a little bit here. it's self-hosted at home on a Raspberry Pi. If folks are interested in that, feel free to ask. Raspberry Pis keep coming up now these days, and I kind of have been anticipating a little bit more like, I'm running on a Raspberry Pi 5 with 16 gigs of RAM. So in a sense, it's like, yeah, it's running on like a tiny machine, a Raspberry Pi, but they're like 4 pretty fast cores now. I've got an NVMe over PCI Express 3.0. Like, this is way bigger than I usually pay for like a cloud instance of any kind, because you're talking like actual money at that point, like at least if you're like indie. I originally ran it on the 4B, and I'm intending to put it back on the 4B, which is like closer to what I would say is like a reasonably like very small machine. I said I wasn't going to talk about data modeling, but the one thing I wanted to say is that LSM trees force you to remove reads from your write path. And I was going to think of a better way to say this. If you're writing data, avoid doing any reads while you're trying to write, or you'll have a bad time with LSM trees. Because I'm me and I say wrong answers only all the time, I kind of like bargained with that, and so I still have some reads in my write path, which is why I had to move from the 4B to the 5. But I will get it back onto the 4B because I know how to remove those final reads, and it has quite a bit of overhead once those are removed. Actually, I think I've got time just to like really quickly. Do I have time? What time is it? Okay. Okay. Hard to schedule. Will this work? Oh yeah, this works. Okay. So, yeah, thank you. Yeah. Okay. Okay. This is like my in the write path. The blue here is how much time I'm spending reading from RocksDB, and the purple time is how much time I'm spending writing. So you really have to remove the reads from your write path if you want to use the LSM tree. Also, deletes are a tiny fraction of the records coming through the fire hose, but because I have like basically uncached cold reads, this blue here is all deletes, and it's taking up like an equal or sometimes more time than creates. Anyway, reads in your write path, don't do it. Even a 4B is fairly powerful. So I have a really old 12-year-old, some very, very old Pi Model B, and it's now running a full Jetstream consumer. So it can really scale down, even though I'm running on a Pi 5, which I feel a little self-conscious about because it's pretty big. And that, where is it? Okay, yeah, super quick demo of the thing running on the Pi, original Pi Model B. I'm cheating here, it's running on the 4B at home. I have the Model B with me, but it runs on this, it does run on this. It backfills like really fast, it's wild. I do offload TLS, so I'm cheating a little bit. It's not doing the encrypted Jetstream. I have it going through Nginx to remove TLS. But this is kind of like the thing I've been working on that I'll hopefully have up publicly later today, which is a kind of lexicon browser for the Firehose. So it's not a full archive at all. It's only storing the most recent sort of like 100 or few hundred records that it sees from every lexicon, but it stores them from every lexicon. So right now, if you want to make one of these third-party apps, and like you can do a Blue Sky thing, but I don't know, Blue Sky Lexicon is kind of overdone. Maybe you're like, oh, Rock Sky, that sounds cool. Like, how do you go and find the people who have Rock Sky like records that you can go and play with? So UFOs gives you a place where you can open up any lexicon and see like sample records that showed up on the real Firehose. Again, I'm showing live Firehose stuff on the screen. Yeah, Tangled, let's see, like we've got all the kind of Tangled things. Like you can build a alternate app view for Tangled. And I wanted to build this because I think like we're at a point where it's not easy to build on atproto yet, and I think we both need like better tools for making it easy to build on atproto, but we also need like more examples of like how easy it is to do some of the cool things that atproto can do. So with the intersection of like a backlink index like I built and this UFOs thing that I built, like you can make the everything app. You can just like, you don't need to build your whole app view. You can just ask UFOs for like the latest records of whatever collections you want, and then you can open them up and see like, oh, this issue in Tangled comment is @link. So my backlink index is indexing that. You can say like, what is that actually pointing to, and get all the content you need to build a front-end JavaScript only view of Tangled if you wanted. So, okay, I'm gonna wrap it up. That's kind of where I'm at. The service layer on top of the protocol is so fresh that there's big gaps everywhere right now, and I'm interested in building out some tools to kind of like be the, calling back to that like traditional architecture, SQL database with a JSON API and a client framework. Like you've got so many choices of like ORMs and like whatever language you want to use to build on top of your SQL database, or your client app, you know, or is React Native or fully native, yeah, I think like my stuff, Microcosm, is my attempt to sort of build out some of the tooling to make building on atproto fun. But I also just want to say like, just because I'm building a backlink aggregator doesn't mean that it should be the only one by any stretch. I think there's 2 more backlink aggregator projects happening right now. And if you wanted to build something and you see somebody else building it, like we don't just have one JavaScript UI framework. There's room for lots, and it's really good and important to have lots so that we can like move forward and find the right abstractions and the services that make sense.
Cool. Thank you so much, Phil. That was great. Okay. Questions for Phil, especially about all of the numerous graphs that Phil had on screen.
Thank you for this. This is fire. 2 questions. One is pretty easy. Second is a little spicy. First is, was it RocksDB that you ended up using?
At the moment, yeah, Rocks.
Cool. The second is, so Christine Limmer-Weber had put out that a series of articles discussing kind of the decentralization of app protocol and like, is it possible, right? Is it really decentralized? How decentralized is it? And I feel like for me, the way I've interpreted a lot of the conversations around decentralization have been like, first it was the PDS, then it was the relay, and then it was something people have started calling, I guess, archival relay, which is really just the app view and like, I think the backlink aggregators that you've been working on. So, and now I know that it is a lot what you described as heavy writes and not a lot of reads. I guess just what is your outlook on not necessarily the decentralization of app protocol, but specifically for a big service that everyone, you know, majority of the entire network relies on right now, like Blue Sky, that would then require both writes and reads?
Yeah, I like that question a lot. I don't want to, yeah, okay, I'll hold, I think working backwards from that, Constellation, which is the backlink aggregator, is written in Rust. Somebody mentioned yesterday, like interfaces in Go are awesome, and Rust traits are awesome. Like interfaces in Go are awesome. Like these tools we have for like modular programming mean that we can like separate the problem into pieces. And so Constellation actually has two storage implementations of a sort of like storage trait that it uses. One is RocksDB on the current data model. I'm working on another one for RocksDB on a better data model. And then the other real one is a sort of like in-memory one that's just nice for like running tests and stuff. But one of the reasons that I like really appreciated being able to define those traits in Rust is that you could plug in fial, which is another key value LSM tree, or what I am pretty keen to try is like plugging in something that's like not an LSM tree. Like, could you drive storage into like a clustered Garnet database, which is this like really cool, fairly new Redis compatible clustering larger than memory data set thing from Microsoft Research, which even supports like tiering your cold data off to object storage. And because that can like operate in a cluster with whatever cool things they do to make that work, you would be able to scale reads on something like that as long as you can drive the right throughput like pretty far. I haven't sort of like found the limits on that. I will say that Raspberry Pi on the 4B, and I'm gonna like be defensive here and say like these are like worst case scenarios. Like it could do 1,000 reads per second of cold like random reads, but while consuming the Firehose, because I have the reads in the write path, it's very cache dependent for that performance. So it can only do about like 300 reads per second while keeping up with the Firehose. But on the 5B, I haven't hit the limit yet. Like it's more than 1,000 writes per second, even with this bad data model. So, and ROX itself can do some replica style things. So even without going to like a fully kind of like separate paradigm, I think there's room to like scale up an index like this pretty high, even on fairly small machines. Yeah, okay, I see more questions. So yeah, but noted about the discussions around decentralization.
Thanks a lot, Phil, that ruled. Yeah, so there's a slide I cut from my talk, and this is my chance to like get it like kind of from your perspective. So I'm really interested in, new experimental ways of building apps. I gave like a pretty traditional, like very top level view of what that looks like. But there's a few different ways we can go about it. And for people who don't want to have their own bespoke indexes, like soup to nuts, like themselves, they have kind of two options, like roughly. One is like, go to these like developer platforms like the Blue Sky API and build on top of that, and they're like very application specific. And then the other one is like to lean on services like you're working on that are like generic indexes. And like I'm really interested in kind of like that side personally. But yeah, I'm curious if you can flesh that out. Like, are there any other kinds of generic indexes that you think are like going to be really useful for app development aside from that backlinks example? And also like anything you could say on like mixing together, hey, I have some custom indexes and I'm augmenting them with these generic ones like running out there. Thanks.
Yeah. Yeah, totally. Yes. I don't have a lot of insight into like more customized indexes, but I think that is something that is always going to be important for people building on atproto. So like, I think like the analogy would be like SQLite. You can do joins pretty far without even thinking about indexes, and then like where you need them, you can be like, oh, I have a hot path here that's going really slow. Let me just throw an index on that. And so thinking about how somebody might use Constellation to build an app, maybe they don't bother like indexing locally. They can just call out to Constellation, get any info they need, and then they find out like, oh, this read pattern requires like an n+1 query over the network. Like that's not going to work for me. And so they end up having to build that into their own local thing. And I think that like every app is going to run into that, but kind of like those indexes in SQLite, like you don't need to index every single column. It's going to be your like bread and butter of your application that's going to require that. So it makes sense that that's where you would want to invest any effort anyway, extra effort. And probably like as your app scales, eventually you might want to bring all of that in-house. And I would love to see kind of like a thinking through what that looks like bringing an index off of something like Constellation and making it really easy to write that into your app view, because I don't know if we have any like well-established patterns for that right now, beyond just like writing to SQL or something and throwing indexes that way.
Thanks for the talk, Phil. I told you beforehand that if I wasn't at Blue Sky, this is probably the type of stuff that I would want to be working on, so super stoked to see you working on it. My question's a little bit similar to Devin, but in the context of like self-hosted Blue Sky, which is something that people have been talking about a little bit, kind of building Blue Sky off of a seed set of users. But then you obviously have the problem that other users can interact with your content. Backlinks would be really helpful for that, for like kind of slowly expanding the seed set. So have you thought at all about how these generic indexes can help users that are building a self-hosted Blue Sky application?
Yeah, 100%. In the way that atproto was designed as a protocol to be able to support something like Twitter, I very much had like Blue Sky in mind, as like Constellation is designed to be something that could self-host Blue Sky. I haven't done it yet, but I think most of the pieces are there if you wanted to kind of like, again, some of those indexes are going to be better than others for it, but I think you could get pretty far in self-hosting your own Blue Sky app view off of Constellation at this point. And I forgot what else I was going to say. App View Lite is the other thing I was going to say. It's just that you know, somebody's already done it. App View Lite is a C# implementation of a Blue Sky app view, which works today. It's using kind of similar techniques to like indexing all of the links and then not indexing all of the content, and collecting based on like your user which posts to archive locally, and then falling back on like fetching from PDS. So I don't know. I feel like we keep talking about this hypothetically as like somebody should build that. As App View Lite, somebody did.
Hi, my name's Ian. Thank you very much for the talk. I really liked all the graphs in particular and the googly eyes on the Raspberry Pis.
Thank you.
I'm curious if they make it go faster, but that's not my actual question. I wanted to know if you had any ballpark numbers on bandwidth or power needs for doing sort of self-hosted things.
Yeah. What I will say about the googly eyes is that it's still running, and I assume because the googly eyes, like I don't know if I took them off. So the Jetstream Firehose in the last 24 hours was 14.5 gigabytes into my house. The transmit path is ridiculous because I'm using RocksDB backup to a local NAS, and so it's counting all of that, so ignore that. But less than 20 gigs a day for the Jetstream Firehose. For power, I don't have the stats offhand, but the Raspberry Pi power adapter is rated 27 watts, so something less than that.
Well, those answers some of my questions, just the graphs. The other pair were, have you experimented around with in-memory databases or just in-memory data structure versions of the services? And have you played around with putting any of this in, say, GitHub workflows and publishing it to public repos? Because as far as I see, like, in terms of reducing the cost and delivering the thing to the whole community, that's the cheapest path I can possibly imagine. Not paying for the bandwidth, because that's in GitHub's data centers. I'm not paying for running the thing, because that's GitHub's data centers. And checking it into a repo lets us all access it as long as it's public. So, A, have you played around with the in-memory database version, gotten different performance characteristics? And B, have you considered putting any of this up in open sourcey clouds?
Totally. In-memory is a really cool idea that I think somebody should do for a backlink index, because like I might be getting close to 100 gigabytes. No, anyway, I don't know exactly how big it is, but I'm eating up in the last day, and it's an LSM tree, so storage stats are weird, but under 2 gigabytes per day increase in size for the index. So you do have to be thinking of a pretty big machine to be able to keep the whole index in memory. I mean, those machines exist. If somebody did it, they'd be able to make an index that like really ripped. I've been focused on self-hosting and like at a small scale, so I haven't looked so much into sort of those cloud options, but I would love for somebody to pursue that. And I just want to say, like, I think that's an important thread to follow because, like, I was hesitant to open my self-hosted thing up to the internet, and I thought, like, I don't know, somebody's going to like start using it, and it's going to like use all this bandwidth to my house and stuff. And like, what I want is for people to self-host it, and like, I don't think anybody else is hosting an instance of Constellation. I think it's over half a dozen like apps using it now, but nobody actually wants to self-host. So, especially for something that's like kind of like a lower level service. Yeah, yeah. And so just to say that, I think like I was a little naive in like expecting that the use case for this would be self-hosting, whereas like I think really people want it to be a service that they don't have to think about. So I think that's a really relevant question. Cool.
Thank you very much. Thank you. Thanks. Well, let's say thanks to Phil and round of applause.